Okay, so let me take a look at the first four examples. We're going to be looking at our counting methods and probability. Okay, so basically counting methods, we're going to be looking at what are all my cases. So let's take a look. For questions 1 and 2, I'm going to represent the sample space using set notation. So there's a new card. It's available in a sedan model or a hatchback model. So when I show up to the store, I can choose a sedan or hatchback models, and then it's available in red, white, green, black, and yellow colors. Okay, so let's see. Let's say I show up here. I'm gonna do what we call a tree diagram. That's what I'm gonna do first. Okay, so let's say I'm here, and I show up, and they tell me, "Do you want a sedan or do you want a hatchback model?" So those are my two choices. Once I make the choice, I have to choose a color. I could choose, if I choose a sedan, I have to choose red, white, green, black, or yellow. If I was to choose a hatchback model, then I have to still go. I have to choose a red, to choose a white, to choose green, black, or yellow. Now, this is going to give me all my possible choices. Let me write in red my choices. I could choose sedan red. So let me just go here. My first choice, now this little bracket thing that we use, that's what we call that for set notation. And I'm gonna call it like, remember how we in algebra you guys wrote for points? You guys use parentheses and then your choices in there. So I'm gonna say my first choice, I had to choose a sedan red. That was my first choice. My second choice was sedan white. Then I could say sedan green, sedan black, sedan yellow. I could also have chosen hatchback red, hatchback white, hatchback green, hatchback black, and let me just close it here, hatchback yellow. So all my possible choices. Okay, that's not that bad. Let's take a look at question number 2. A jewelry store sells gold and platinum rings. Each ring is fitted with a ruby, sapphire, emerald gemstones. Okay, so let's see. Let's say I'm here and I show up. Here I am. And then I show up to the store and they said, "Do you want gold or do you want platinum?" Okay. And then let's say I choose gold, then they're gonna tell me, "Do you want ruby, sapphire, or emerald gemstone?" Let's say I was to choose platinum, they will say, "Okay, do you want ruby, sapphire, emerald gemstone?" So my possible choices is gonna be gold ruby, gold sapphire, gold emerald, or I could have chosen platinum ruby, platinum sapphire, or platinum emerald. Okay, so that's basically how we do our choices. Now, when we find out here for questions 3 and 4, I'm just interested in how many choices did you have. Question 1 and 2, I wanted to see all the choices. But questions 3 and 4, I just want to know how many do you have. You can make a list, you can make a tree diagram, you can multiply it. There's many rules. So let's take a look. An ice cream stand offers single scoop waffle cones or bowls. And then I have four flavors available, which is strawberry, chocolate, vanilla, and mint chocolate. I could I could choose a tree diagram. Okay, how does the tree diagram work? Okay, let's remember. Let's say I'm here, and then I show up, and then they say, "Do you want a single scoop waffle cone? Let me use C for cone, or do you want a bowl?" And then once I choose, let's say I said cone, then they're gonna tell me, do you want strawberry? Do you want chocolate? Do you want vanilla? Or do you want mint chocolate chip? And if I say bowl, they're still gonna ask me, do you want strawberry? Do you want chocolate? Do you want vanilla? Do you want mint chocolate chip? I can count how many choices I have at the end. I can make a list, kind of like how we did for number 1 and 2. Remember how in black I will do a tree diagram, in red that's my list. I can count how many choices are there. So if I count them, I go 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna have 8 possible choices. That's my answer. But I'm like, wait a minute. On the instruction, it says something about multiplying. Okay. When you show up on your first choice, cone or bowl, on your first choice, how many choices do you really have? A cone or a bowl? Well, you got two choices, right? On your second choice, how many choices do you have? Each of my lines here are going to represent a choice. Well, there were four flavors, right? So I had four flavors. I see how many choices I have, and to be honest, I'm just going to multiply them. 2 times 4 is 8. Let's take a look at number 4. 5 books need to be placed on the shelf. You randomly arrange the books on the shelf from left to right. So I'm more like, okay, there's 5 books. Let me just, let's say that's a book. That's another book. Third, fourth, and 5. Okay. So, and I'm gonna arrange them. So on my far left, how many choices do I have for this one? Well, 5 books. Let's say I chose that one, so I'm gonna take it out. My second book, how many choices do I have left now? Oh, there's 4. Okay. Boom, let me take a book out. My third choice. I see 3 available books, right? So I have 3 choices. Boom, let me take one out. Now my fourth book, well, I only got 2 choices. And then on my last book, well, I only got 1 choice. Okay, now multiply those out. 5 times 4 times 3 times 2 times 1. And it's going to tell me I have 120 choices. Oh, that was nice. So, yeah, this definitely, I'm not going to do this one on on the tree diagram. Too many choices. I'm not going to list. I'm not going to make a list because it's too many choices. So I'm going to go multiplication. So let me do one thing here. You guys are like, wait a minute. When I had to do the sample, could I have done multiplication to know how many choices I was going to have at the end? Yeah. When you showed up to a car, you had 2 choices, sedan or hatchback. And then you had to choose a color. And then you had 5 choices. If you see, I have 10 different choices. Like, wait a minute. How about here? When you showed up, you had your first choice was gold or platinum. So you had 2 choices. And then you had to choose a ruby, sapphire, or emerald gemstone. You had 3 choices. Multiply them, and you should see that you had 6 possible choices. Nice. This is fun.